days I may win, and some days I may fail. You say that I'm small, but I fight on major scale. And even when I lose, look how they say my name. And even when I'm hopeless, I don't lose my focus. I got the strength, and I got the power. Be crazy, no lazy, be put in the hours. Be ready to fight, but not ready to lose. And even if I did, I would get it back too. I failed once, and I failed twice. Not ready to back down, cause I know I still fight. The haters still hating, and I say bye-bye. And man, I win the game, I'll be the only one flying. I never give up, cause that's just for losers. The ones who stay strong are the ones who become rulers. Now it's up to you if you wanna give up or believe in yourself and find your way out.
It's all about grit, all about resilience. You gotta stay strong, you gotta have perseverance. It's no gain, no pain, no gain. All strain your efforts, don't go in vain. It's all in resilience. All about grit, all about resilience. You gotta stay strong, you gotta have perseverance. It's no gain, no pain, no gain. All strain your efforts, don't go in vain. It's all in resilience.
It's all about resilience, it's all about pain. Cause that's my opinion, wanna take the step, cause that's easier than a brick. I'm learning my lessons from the mistakes that I did. We're back for the throne, fighting it but we're alone. Whoever know, we're on our own. Never knew we were limitless, the harbor from my heart. The thought is what I got, it comes from my brains. Cause it's in my veins, I fight those mistakes that I go into straight lines. When I wanna do, I gotta grow. And the place I know is where I have to go.
It's all about grit, all about resilience. You gotta stay strong, you gotta have perseverance. It's no gain, no pain, no gain. All strain your efforts, don't go in vain. It's all in resilience. All about grit, all about resilience. You gotta stay strong, you gotta have perseverance. It's no gain, no pain, no gain. All strain your efforts, don't go in vain. It's all in resilience.
Namaste, I am Shastri of grade 7A. Here's the artwork I created on the topic Space and Scientific Explorations. Space in the Future. In my artwork, I've depicted robots taking over Mars. These robots will be able to walk, talk, think, and work like us humans. NASA has sent a few robots into space, and I believe that these robots could evolve in the future and take over Mars. I've also added a skyline. There is a tunnel through which cars can pass through too. These will be built by robots. This is a fictional imagination of mine, but I do believe that this could actually happen in the future. I hope you like my artwork. Thank you.
Namaste, I'm Tanvi Kaliga from grade 7A, and this is the artwork I have created on the topic Space and Scientific Explorations. In my artwork, I have tried to depict an astronaut coming from a spaceship who is trying to obtain a special kind of rock found in Saturn's ring using a special kind of device. This rock apparently has the ability to release oxygen when heated. This is a fictional thought of mine, it is not real. However, I believe that such things could be found in the future. Thank you and hope you like my artwork.
Namaste, students of grade 7. My name is Arav Saxena, and today I am going to be talking about space from the skit Martian. Space, everywhere. Space has always been a very mysteriously interesting topic for us humans, and therefore humans have probed it deep. This time space has grabbed the attention of many students, and it is fantastic to see that beyond these space ideas. Let's start with the idea of shifting from Earth and settle somewhere else new in the universe. Sounds interesting. The students have tried to terraform the moon and Venus for human habitation. Seeing overpopulation on Earth, it is indeed a revolutionary idea to shift. For this, an extraordinary infrastructure is needed. How to make it habitable? Students have suggested many ideas. You never know, 100 years down the line, and we are on Venus.
Vijesh Nitin Pranav Kannan. Terraforming step by step. Had enough of Earth? Let's live somewhere else from 7B.
Introduction. Log year 2080. Humanity wants to expand its empire. The next stage of civilization needs to happen soon due to overpopulation. The solution has been thought up by the smartest minds all over the planet. It has always been around but not been possible or viable yet. What is it? Terraforming. Terraforming means changing how a planet is to suit our needs.
Introduction. The last pioneers of humanity were astronauts who ventured out into space and the moon. But now they embark on a greater expedition, more perilous but more perilous. But as Armstrong said, one small step for man is one giant leap of mankind. And now we take the biggest leap mankind has ever taken.
Log 1. Venturing outwards. This is it. This is the big moment. You have been preparing for years, and you are now in space. The space shuttle is heading for the moon, Earth's natural satellite, which will now be a home. It is 2080, and human civilization is expanding. The moon will be hard to colonize, and probably many dangerous things will happen. But scientists believe that by 2150, 75 years later, the moon will be habitable. Imagine in 2150, people will be able to see the Earth in the sky.
Moon, our own lunar satellite, and maybe even a new home. The moon is why the moon exactly? The moon is a desolate, decrepit, derived landscape which scorches during the day and freezes during the night. The atmosphere is paper thin. There is no ice to work with and no life either. The moon, to put it simply, is nothing but a ball of grey dust. So the question does arise: why on earth are we trying to live on the moon then? Surely there's better places to be, right? Thing is, the moon is the closest to the earth. If we do make a base there, we can use it as a stepping stone for the next level, Venus.
Log 2. Why the moon exactly? The results would be amazing. The moon can be used as a sandbox to develop new technologies to aid us on Earth. The moon has a lot of untapped resources. It would start a second space race, laying the foundation for humanity to expand through the solar system and beyond. So how would we build a moon base today?
Log 3. Exploration outpost settlements. Throughout history, settlements have always happened in three stages: exploration, creating outposts, and finally, settlements. Explorers would arrive on a new land, putting up the flag and taking claims. However, they didn't stay. Astronauts have already done that for us. An example, think of Armstrong. He landed on the moon, planted America's flag, and came back home again. Throughout the years, we have charted and mapped the entire moon. Next up are outposts. Outposts were just that, temporary homes to try and use the land's resources. While the people did stay in the new place, they relied primarily on their homeland, or planet in this case, for resources. Thus, some failed. The others maintained and established their presence, creating the first settlements in a new world.
Log 4. The specifics. Building a colony on the moon is not that big an investment on the global scale. It would cost between 20 to 40 billion dollars and would get finished in one decade. We have already explained the benefits of the moon, and which are resources, possible new technologies, more space, and a stepping stone for more. So if the moon is so amazingly perfect, why aren't we doing it? Unfortunately, governments have more pressing and dynamic issues than long-term investments, and thus it is a dream for most of us to live on the moon someday. But scientists theorize that it is possible today to start building outposts on the moon, but it would possibly take much longer than a decade to fully live, breathe, and populate the moon. From now on, we will assume that governments have invested on moon colonization.
Log 5. The moon is not the most welcoming space friend. Now, the challenge of capital and people has been overcome, but the moon isn't really gonna welcome us with open arms. One moon day is equal to nearly a month in Earth days, and there is a difference of at least 300 degrees Celsius between morning temperatures. The moon's thin atmosphere cannot protect against meteor crashes and cosmic radiation. The moon is covered with jagged space dust. If a person breathes that in, their lungs will get poisoned and suffocated. Not a nice way to go, I'll admit. The moon is hard, but humanity is good at hard things. Let's do this. Phase 1. Picture. Phase 2 by 2028.
The third stage is settlement. We will start making permanent colonies, although the astronauts will keep moving from places to places, making the groundwork for lunar bases. Geothermal and solar energy can be used for generating power, as the morning is for 14 Earth days. Lunar ice can be melted to grow food until we are able to put down genetically modified plants which can grow on the moon. Hydrogen cells will hold power during the long nights, extending the astronaut stays. It can also be split into hydrogen and oxygen, rocket fuel. By carrying fuel from the moon, we can create a orbital depot where other missions can refuel. It is also easier to launch rockets from the other moon. This may help in the terraforming of other planets.
However, this isn't a true colony yet. If funding stops, living on the moon stops as well. To live independently, the moon colony must become self-sufficient via regularly trading with the Earth. Private contractors would now start arriving to the moon, looking to get rich from all the resources. They could extract precious metals like gold, uranium, titanium, and platinum and sell them. Uranium can also be used for nuclear energy. Helium 3, which is abundant on the moon, can be used for nuclear fusion reactors. This may be exported to Earth for cheap and durable and clean energy. Asteroids could be mined and trade flourishes. The settlement is in the third phase, is self-sustaining and economically productive.
The base can be made using lunar resources. The moon has everything necessary to make concrete. Thus, moon settlers can now trade, build, and sustain themselves independently from the Earth. The orbital depots are now powering ships to Venus, efficiently starting the next phase of colonization.
Venus, hell to home, a makeover on a grand scheme. Log 6. Let's conquer hell. When someone says hell, what do you think of? Lava pits, volcanoes, red zone, evil demons, bats and sulfur, right? Well, I can give you one simple word to list all above, excluding the demon bats. What is that word? Venus. Venus is named after the Roman goddess of love, but you can bet that you really won't love Venus itself. Let's try to land there, shall we? Oh wait, the sulfuric acid in the clouds just melted our rocket and we have landed in a volcano. Well, let's land there with an acid-proof rocket and fireproof suits. Awesome, we made it to the surface, but there's a catch. Our bodies have just exploded due to the pressure. I think you agree with me that Venus is horrible, but then why are we transforming Venus?
Log 7. Why Venus? As previously established, it is impossible to even touch the Venusian surface. Why then are we terraforming it? Venus is like the Earth in size and geographic composition. It has similar gravity as well. Venus, however, has much more carbon dioxide than Earth will ever have. On Earth, a change between zero point 0.3 to 0.4% of carbon dioxide causes flood and global warming. Venus has 97% carbon dioxide and 3% sulfur dioxide in its atmosphere.
Log 8. Specifics and a tad bit of stupidity. The moon was just a stepping stone and Mars is a power devoid toxic planet. Venus, however, is perfect, but not yet. Terraforming Venus will make it look like anything else is cakewalk. Compared, compared to the moon 70 years or so, we can expect Venus to at least take 1 millennium, 1000 years to finish. Let us assume for now that there is already moon base which has been established and humanity in general is much more advanced and ambitious. We also assume that skyhooks are in implementation. Additionally, there are no pressing issues on Earth itself and the capital and manpower is ready and roaring. So how do we make how do we make hell a home? Let's do it.
Log 9. Colonizing Venus. Before doing anything else, we need to cool Venus down and remove the gas that makes up the heavy atmosphere. How do we do this? Our first option is solar powered laser beams, which release beams out of much intensity that Venus' atmosphere is blasted out into space. But this would need thousands of times this energy at our disposal and take tens of thousands of years to completely remove the atmosphere. A second option is called securitization. It relies on chemical reactions between carbon dioxide and calcium oxide to form calcite. We could mine elements such as calcium or magnesium and mercury and shoot it to Venus using a skyhook or Mars driver systems, which are gigantic space slingshots. This, however, is a waste of time and money. And now we reveal the most ridiculous idea, but the most plausible one as well.
Locked down. No sunshine for you. Sunshine. The most ridiculous idea is to make Venus cooler is to put it in the shade. Quite literally. By making a mirror, we can stop the sunlight. It does not require a whole lot of resources. Making one flat object and putting it so close to the sun will turn it into a solar sail, which can cause major destruction. Thus, this almighty mirror will be made of different pieces and will be somewhat conical in shape. Annular slats on the mirror are angled and can reflect sunlight from one mirror to the next. There would also be a supportive mirror behind Venus to reflect any other light. Now, there is no sunlight to Venus. The first few decades, the atmosphere slowly cools down but remains very dense. After around 60 years, it reaches a temperature of minus 31 degrees. A huge flood rains down on Venus. As CO2 is liquefied due to the insane pressure, it will rain all over Venus continuously for 30 years more. Puddles of liquid CO2 turn to vast lakes and oceans at minus 56 degrees. 110 years later, at minus 81 degrees, the oceans freeze over and the rain turns to snow. Most of the CO2 is now solidified at 3 times Earth's pressure, and most of the Earth atmosphere now has nitrogen.
Venus can now be walked on. We don't mind freezing and suffocating to death. However, at some point we will have to warm up the planet up again. If the excess CO2 all heats up and gets back to the atmosphere, we will be back to square one with a lot less motivation and money. The obvious solution to this is to shoot it out using the Mars drivers mentioned before. This will take another 150 years. So 300 years after this insane venture, CO2 levels should be alright. Next up is water, which is simple enough to solve. Europa, Jupiter's moon, has twice as much water as Earth's ocean. Rather than lugging the full thing back, the ice could be shot into space using the drivers and then caught by skyhooks, launching it directly and quickly and efficiently into the Venus. The Venus tethers drop the ice down into the atmosphere where it falls as snow. Additionally, these tethers also shoot out the excess CO2 and nitrogen. 500 years later, Venus is covered in nice, shallow, frozen oceans and a few hundred meters deep. The planet would look a lot different from what it is today.
800 years after humanity started to transform Venus. Fudge! Okay, again. 3, 2, 1. 800 years after humanity started to terraform Venus, a few continents and countless islands have begun to form. Venus has started to look like Earth. Now comes the last phase of terraforming and the grandest one. We will now be creating the atmosphere and populating Venus with flora and fauna. One Venus day is equivalent to about 116 Earth days. Rather than removing the mirrors and grilling half of the planet, we can use more mirrors to create a day and a night cycle to melt the oceans. This would give us immense control. The atmosphere now has to be the perfect amount of CO2 but no oxygen. Instead, it is 98% nitrogen. Thus, the first living breathing inhabitants of Venus will be trillions of nitrogen fixing cyanobacteria. They will convert the nitrogen into oxygen just like they did on Earth 3.5 billion years ago.
On land, the colonists will be grinding down the former Venusian surface to make soil for the new nitrogen fixing plants to grow in. Eventually, 500 years later, billions of trees spread, creating large continental forest. Venus has turned green. To speed things up, CO2 is strategically released. Areas with plants could get extra daylight from the orbital minutes. As our knowledge of genetic engineering grows, we could modify animal and possibly ourselves to survive better and adapt to Venus better. It has now been 1,300 years since the project began. The Venusian flora and fauna have adapted. However, humans may take longer to adapt, taking as long as 1,000 years more until the atmosphere is good for us. Maybe we could use the ice and frozen CO2 orbiting the skies above to create fuel to go and terraform another planet. Maybe that other planet could be Mars. But that terraformers is a story for another day.
Billions of people have decided to make this new world their home. Animals are being tamed, cities are being constructed. Their inhabitants will look at how Venus once was, the most hostile place you could imagine. How it took hundreds of years to freeze hell and ship in oceans, and another 1,000 years to make the air breathable. They will hardly believe it.
Maybe it's not so easy to do what we have said here and in all the possibilities. There may be tons of things going wrong, but it is possible, and with technology which is in reach of slightly more advanced, human society which is more motivated to go into space. Conclusion. We hope you love this insane journey through the stars.
Acknowledgements and bibliography dedicated to Bhagyashree ma'am and Pratima ma'am for such an amazing, interesting opportunity. Our friends and family for being with us and reviewing at each and every step. Earth's marvelous scientists and astronauts who make it possible for us to dream this way. Bibliography Kurzgesagt and Koranov, two interesting science channels, you should check them out. Google, Wikipedia, and NASA.gov for easy and quick information at our fingertips. Bing Images Microsoft Stock for the images used in the PPT. Thank you.
To reach there, we need satellites, but alas, it is an expensive affair. For that, we need a lot of fuel. So, some students suggested a new technique of sending rockets with minimal fuel. What is that? How? It is called as skyhook, where a tether is used to send the rocket with minimal fuel. So, it will rotate the rocket like a Beyblade with a lot of energy and with minimum fuel. How economical!
Namaste, my name is Vishwak Lakshati.
Namaste, my name is Arish Reddy.
Namaste, my name is Suha.
Acknowledgements inspired by John McCarthy and Kierkegaard. These are the table of contents. Introduction. Getting to space is difficult, as you all know. Right now, it's like going up on a mountain on a unicycle with a backpack full of explosives. Incredibly slow. You can't transport a lot of stuff and you might die.
A rocket needs to reach a velocity of about 40,000 kilometers an hour to escape from the Earth. To get to that speed, to, to get to that speed, rockets are mostly containers full of fuel with a tiny type of payload. This further adds weight, requiring more fuel, which adds even more weight. It's also bad if you want to go to other planets because you need a lot of heavy stuff if you want to survive and maybe even come back. So, is there a way to get to space with less and feel more playful? A nice thing that solved most of our transport problems is, is what you call infrastructure, whether it's roads for cars, ports for ships, or rails for trains. We have made it easier to go to places. We can apply the same solution to space travel. I pass it on to Suhas. I mean Vishwa.
The tether. Space infrastructure will make getting into orbit and out to the moon, Mars, and beyond easier and cheaper. Wait, but what exactly is space infrastructure? Unlike an Earth space elevator, which is currently science fiction, there is a simple yet promising technology that does not require new science, magic materials, or huge investments, and that has been tested successfully in orbit already. A cable and a weight known as a tether. The concept is so simple it's surprising. What if we put tethers, hundreds or thousands of kilometers long, into space, and had spacecraft use them as ladders to climb to higher altitudes and gain speed? This concept is known as the skyhook. It works even better if you make it spin. A counterweight holds a long cable in place while it rotates around a circle. A rotating tether slows down its tip relative to the ground at the bottom and speeds it up at the top like a catapult. This means that you can transfer energy from the tether and get a massive boost when released. More or less for free, equal to twice the tether's rotation velocity. Specialized fibers already exist that can survive the extraordinary stresses a skyhook would need to be protected against, the cuts and collisions from debris and meteorites. Xylon, a synthetic polymer that we can thread into a web of redundant fibers to make the tether.
So I shall pass it on to Suhas.
The magnitudes. Since our skyhook would pass over the same spot many times a day, this would allow a small this would allow small, reusable shuttles to catch with it. Of course, it's not that easy. At its lowest point, the tether tip is dashing through the atmosphere at around 12,000 kilometers per hour. Because of Earth's atmosphere, we can't lower the skyhook too much for it. We will get too hot from air friction. So it will dip to a height of 80 to 150 kilometers above the surface of the Earth and no lower. To match this, we'll need a specialized spacecraft that can get to the tether. While this isn't exactly easy, it's still much cheaper than getting a big tin can filled with a rocket fuel to go 40,000 kilometers per hour. Catching the tip will be a challenge too. There's only a short time window of 60 to 90 seconds to find a tiny thing in the sky, moving at Mach 12. So, to make this easier, the tip could have sort of fishing like line a kilometer long with a navigation drone that helps the spacecraft connect.
Suhas shall continue.
Orbital energy. Another challenge is keeping our skyhook in orbit. As more and more ships latch onto it and pull themselves up, they use up the momentum that keeps it in place. If we don't do anything, it will slow down and crash into the atmosphere. But here we can cheat the universe a bit. The skyhook is a battery of orbital energy. It's possible to balance the payloads coming in and being sent off. Arriving ships bringing humans and materials home to Earth add energy to the tether, which it can give to other ships departing into space. This way, the tether doesn't lose any energy. The more we use it, the cheaper it gets. If we're still losing energy with each boost, we can recover it with a small electrical or chemical engines that regularly correct the tether's position.
Martian skyhook. But nowadays, the space travel trend isn't always to Moon, it's to Mars. A set of tethers, one around the Earth and one around the Mars, could make trips between the planets fast, straightforward, and low cost. Compared to the rockets, the Earth tether would sit in low. Compared to the rocket, the Earth tether would sit in low Earth orbit to grab people and payloads and fling them off to Mars. The Mars tether catches them and slows them down for a landing on the surface. In the direction the tether could pick up a vehicle traveling through Mars's thin atmosphere at only about 1000 kilometers per hour, not much faster than our airlines on Earth, and fling it back to Earth to be caught and lowered down. The tethers could shorten trips between both planets from 80 from 9 months down to 5 or even 3, and reduce the scale of rockets required by between 84 and 96%. Even better, people may be able to travel in relative luxury as we could afford to invest in passenger comfort. The other would be first class seats to Mars. Together, travel around Earth and Mars could provide the rapid and cost efficient transportation before that would make space travel affordable. I pass it on to Vishwa.
Mining, but let's go further. Starting from low Mars orbit, a tether could boost ships to the asteroid belt. The first craft sent to a new asteroid would need rockets to slow down at its destination. The first craft will then form a tether on the asteroid. Subsequent arrivals may find a tether waiting to catch them after the mining and send them back to their planet for free. Getting to asteroids cheaply is a major factor in opening up the resources of the solar system. Precious metals and valuable minerals could be delivered to Mars just weeks after they were cut out of their asteroid. They would be the perfect building blocks for our interplanetary civilization.
So what shall recite it from here?
Expansion. But why stop here? Mars moons are very convenient. No other moons in the solar system orbit that close to their planet. Phobos is so heavy that we don't need to worry about it slowing down. Make it the perfect attachment point for super tethers just under 6,000 kilometers long. The lower tip would fly just over the surface of Mars and be very easy to catch. The upper tip can fling ships all the way to Jupiter and Saturn. The same super tether can also bring the inner solar system closer. Venus and Mercury are a single swing away. Unlike Mars, they're bursting with solar energy and are rich in minerals. In the long term, nothing is stopping humanity from constructing a zero propellant transport network for the terrestrial planets. Centered on the Martian moons, tethers are a comparably cheap and sustainable solution to making space travel affordable and the rest of the solar system accessible for exploitation and exploration. Considering that we have the technology to build them today, there's no really good excuse to wait any longer. Parts of the solar system are far, far away, but they could be very close just a swing away.
Namaste. I am Sanvi Datta from grade 7A and this is my artwork on the topic Space and Scientific Explorations.
I believe there is water vapor in the space boundary of Saturn which will be discovered by scientists in the future. This water vapor will be transformed into water due to the atmospheric pressure which will allow life to be possible in Saturn. The ring of Saturn will be converted into a water body with the capability to attract the burning meteors towards it, which will protect the Saturn from meteors. Jellyfish will be the first aquatic animal in the space. Hope you like my painting. Thank you.
Namaste, I'm Laksha Chilumuru from grade 7A and I would like to show the painting that I have made for the topic Space and Scientific Explorations.
We have discussed so many novel ideas on space, but we still don't mention ISRO and their contribution in space research. Not possible. Their projects like Chandrayaan and Mangalyaan need no introduction. ISRO created history when Mission Moon discovered water traces on Moon. No wonder our students are inspired by them.
Mangalyaan is a space probe orbiting Mars since 24 September 2014. It was launched on 5th November 2013 by the ISRO. It was India's first interplanetary mission and it made the fourth space agency to achieve Mars orbit. India is the first Asian nation to reach the Martian orbit and the first nation in the world to do so on its maiden attempt. The Mars Orbiter mission probe lifted off from the first launch pad at Satish Dhawan Space Center, Sriharikota Range, Andhra Pradesh, using a PSLV rocket C-25 on 5th November 2013. The space agency had planned the launch on 28 October 2013 but was postponed to 5th November following the delay in ISRO's spacecraft tracking ships take up predetermined positions due to poor weather in the Pacific Ocean. The Mangalyaan probe spent about a month in Earth orbit, where it made a series of 7 body-raising orbital maneuvers before the trans-Mars injection on 30th November 2013. After a 298-day transit to Mars, it was put in Mars orbit on 24th September 2014. ISRO originally intended to launch MOM with GSLV, but the GSLV failed twice in 2010 and still had issues with its cryogenic engine. Waiting for a new batch of rockets would have delayed the MOM for at least 3 years. So ISRO opted to switch to the less powerful PSLV. As PSLV was not powerful enough to place MOM on a direct to Mars trajectory, the spacecraft was launched into a highly elliptical Earth orbit and used its own thrusters over multiple perigee burns and to place itself on trans-Mars trajectory.
The mission is divided into 3 phases. The geocentric phase, which lasts from 5th November to 30th November 2013. It consists of the launch, 7 orbit-raising maneuvers and trans-Mars injection. The heliocentric phase, which started from December 2013 to 22nd September 2014. In this phase, 4 trajectory corrections were originally planned, but only 3 were carried out. The heliocentric phase, 24th September. It consists of the Mars orbit insertion. The 15 kg scientific payload consists of 5 instruments. Lyman alpha photometer, methane sensor for Mars, Mars exospheric neutral composition analyzer, thermal infrared imaging spectrometer, Mars color camera.
Take off the time bomb, let Felicity fly. Armor the airlock, blanket the bedrock, kiss the planet goodbye. Dear God, I was terribly lost when the galaxies crossed and the sun went dark. But dear God, you're the only North Star, I would follow this far. galaxies crossed and the sun went dark. But dear God, you're the only North Star. I would follow this far.
Chandrayaan 1. Chandrayaan 1 was the first Indian lunar probe under the Chandrayaan program. It was launched by the Indian Space Research Organization in October 2008 and ran until August 2009. The mission included a lunar orbiter and an impactor. India launched the spacecraft using a PSLV XL rocket on 22nd October 2008 at 0052 UTC from Satish Dhawan Space Center at Sriharikota, Andhra Pradesh. The mission was a major boost to India's space program, as India researched and developed its own technology to explore the moon. The vehicle was inserted into lunar orbit on 8 November 2008. On 14 November 2008, the Moon Impact Probe separated from the Chandrayaan orbiter at 1436 UTC and struck the South Pole in controlled manner, making India the fourth country to place its flag insignia on the Moon. The probe hit near the crater Shackleton at 1501 UTC, ejecting subsurface soil that could be analyzed for the presence of lunar water ice. The location of impact was named Jawahar Point. The estimated cost for the project was 386 crore. It was intended to survey the lunar surface for over a two-year period, to produce a complete map of the chemical composition at the surface and three-dimensional topography. The polar regions are of interest and as they might have water in ice. Among its many achievements was the discovery of widespread presence of water molecules in lunar soil. After a year, the orbiter started suffering from several technical issues, including failure of the star tracker and poor thermal shielding. Chandrayaan-1 stopped communicating at 20:00 UTC on 28 August 2009, shortly after which the ISRO officially declared that the mission was over. Chandrayaan-1 ran for 312 days as opposed to the intended 2 years, but the mission achieved most of its scientific goals. On 2nd July 2016, NASA used ground-based radar system to relocate Chandrayaan-1 in its lunar orbit, more than 7 years after its shutdown. Repeated observations over the next 3 months allowed a precise determination of its orbit, which varies between 150 and 270 kilometers in altitude every 2 years.
The primary objective of the mission is to develop the technologies required for designing, planning, management and operations of an interplanetary mission. The second objective is to explore Mars's surface features, morphology, mineralogy and Martian atmosphere using indigenous scientific instruments. ISRO plans to develop and launch a follow-up mission called Mars Orbital Mission 2, MOM2 or Mongolian 2, with a greater scientific payload to Mars in 2024.
Chandrayaan 2 is the second lunar exploration mission developed by the Indian Space Research Organization after Chandrayaan. It consists of a lunar orbiter and included the Vikram lander and the Pragyan lunar rover, all of which were developed in India. The main scientific aim is to map and study the variations in lunar surface composition, as well as the location and abundance of lunar water. On 12th November 2007, representatives of the Roscosmos, the Russian Space Federation, and ISRO signed an agreement for the two agencies to work together on the Chandrayaan-1's follow-up project, Chandrayaan-2. ISRO would have the responsibility for the orbiter and rover, while Roscosmos was to supply the lander. The Indian government approved the mission in a meeting of the Union Cabinet, held on 18 September 2008 and chaired by Prime Minister Manmohan Singh. The design of the spacecraft was completed in August 2009, with scientists of both countries conducting a joint review. Although ISRO finalized the payload for Chandrayaan-2 on schedule, the mission was postponed in January 2013 and rescheduled to 2016 because Russia was unable to develop the lander on time. In 2012, there was a delay in the construction of the Russian lander for Chandrayaan-2 due to the failure of a Russian mission to Mars, since the technical mission issues connected with the other mission, which was also used in the lunar projects, including the lander for Chandrayaan 2 needed to be reviewed. When Russia cited its inability to supply the lander even by 2015, India decided to develop the lunar mission independently. With the new mission timeline for Chandrayaan 2 and an opportunity for a Mars mission rising with a launch window in 2013, unused Chandrayaan 2 orbital hardware was repurposed to be used for the Mars orbiter mission. Chandrayaan 2 launch had been scheduled for March 2018 initially but was delayed to 2019 due to a few changes made in the spacecraft. It was launched on its mission to the moon from the second launch pad at the Satish Dhawan Space Center in Andhra Pradesh on 22nd July 2019 at 9:13 a.m. UTC by a GSLV Mark 3 M1. The craft reached the moon's orbit on 20th March 2019 and began orbital positioning maneuvers for the landing of the Vikram lander. The lander and the rover were scheduled to land on the near side of the moon in the South Polar region and conduct scientific experiments for 1 year, which approximates to 2 Earth weeks. A successful soft landing could have made India the fourth country after the Lunar 9 from the Soviet Union, Surveyor 1, United States, and Chang'e 3, China, to do so. However, the lander crashed and deviated from its intended trajectory while trying to land on 6 September 2019. According to a failure analysis report sent to ISRO, the crash was caused by a software glitch. ISRO will reattempt the landing in August 2022 with Chandrayaan 3.
With sending too many satellites into space, it is leading to congestion. Some students are very worried about it as it is going to collide with each other. It's terrifying. So, some novel ideas again by these future space scientists. How about repellite? What's that? We know poles repel. So, attaching two magnets on both sides of the satellites will help them repel from each other and thus can help in preventing collision.
Repellite, solving the problems of the future. The work distribution. Rehan and Mellon, PPT. Abhinav, model. Rehan, idea. Mohak, feedback form. Problem. With the satellite population drastically increasing over the past few years, and possibly many more in the future, we cannot guarantee against a few mishaps or crashes. To limit the loss of money, equipment, and maybe even life, we need a safety system in place. The solution. Our idea, the repellite, includes the idea of using magnets to stop satellites from crashing into other satellites. We do this with the help of magnets. As we all know, like poles repel each other. We plan on using big strong magnets and try to make them have the like pole based on the like pole face the like pole of the satellite based on where we launch it.
Oh, that's cool, but how does it work? Well, it's extremely easy to picture it working. Have you ever played with magnets before? If not, then you must know that the magnets with the same pole repel each other. So, if I put two south pole magnets together, they'll try to get as far as away from each other as possible. We can exploit this property and attach them on the side of satellites. So, if they ever get dangerously close to each other, they will repel. Frequently asked questions. What if the magnets are so strong they will knock the other satellites out of the orbit? The magnets will be strong, but won't be so strong enough to knock the other satellites out of the orbit. What if they are so strong that they knock out their own magnets? The same answer as above. We'll make sure that they're not strong enough. Here's a diagram. It shows the south pole magnet repelling the south pole of a magnet. When they both get close to each other, it's they're repulsing away. A few problems. We have identified a few problems with our idea. These problems need further brainstorming or solutions. Problem. If someone accidentally puts the other pole magnet on a satellite, they will get more and more attracted to it and might lead to a massive crash. Temporary solution. We can make a sensor on the satellite or the repellite, which detect if it's moving closer to a magnet and disable the magnet. For this to work, we need to use electromagnets instead of magnets.
Money required. We need around $100,000 to get this idea in the open and inspire the governments of the world to use their money to add this to their satellites. It will cost a bit of extra money for them, but it's effective in the long run. Now, we'll turn our attention to Abhinav, who will be showing us a completed prototype demo model.
Hello everybody, I'm Abhinav from class 7B and I'll be showing you the model of the Repello. So this is the satellite and this just assume this is a rocket taking off from Earth. So the satellites will have more magnets than two, but it'll still have the same effect. So for example, it's just floating over here, like over in the middle of the pathway of the rocket, and the rocket's taking off. So once it's like really it's about to collide with the satellite, it'll slowly repel because the rocket also has a magnet on it so that it doesn't collide with each other. This is like mainly used in the future because there's gonna be a lot more satellites than we have right now. Thank you.
Conclusion. The people who made this idea were Rehan and Nalan helped with the PPT. Abhinav made the model and Mohak made the form. We thought of the increasing space population of satellites and rockets. We thought a and a budgeted idea. For us average 7th graders, this sounded like a great idea. We really hoped you liked this project. Team Repellent. This is a feedback form. https short url dot at slash fktf0. Thank you.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, lift off! We're Bounce Patrol, astronauts, we travel the galaxy. Flying through outer space is where we love to be. We float inside our rocket ship, it's zero gravity. Join us on our mission of discovery. Outside our window there's a million stars and more. Planets, moons, asteroids for us to explore. If we're lucky now and then we get to meet some aliens. Greetings, Earthlings, would you like to be our friends? We'd love to be your friends. We're Bounce Patrol, astronauts, we travel the galaxy. Flying through outer space is where we love to be. We float inside our rocket ship, it's zero gravity. Join us on our mission of discovery. There's fun and adventure to be had everywhere. Flying through outer space without a care. One day on a mission, we landed on Mars. Ran into some Martians who played guitars. We're Bounce Patrol, astronauts, we travel the galaxy. Flying through outer space is where we love to be. We float inside our rocket ship, it's zero gravity. Join us on our mission of discovery. We're Bounce Patrol, astronauts, we travel the galaxy. Flying through outer space is where we love to be. We float inside our rocket ship, it's zero gravity. Join us on our mission of discovery. We're Bounce Patrol, astronauts.
What happens if someone gets stuck on Mars? It would take 4 years to send any help from Earth to them. So what do they do in the meantime? This is what is shown through the skit Martian.
Group of astronauts were ready to land on the red planet in the Ares 3.
You've got the perfect velocity to land.
We are ready to land.
Okay, the boosters are at 100% and we are ready to land on Mars.
Velocity is 2.4. Good to go.
As soon as they landed, they were directly hit by a storm.
Instead of going back, let's wait out the storm.
Oh, but we have orders to abort the mission. I repeat, Ares 3 abort mission.
Let's wait it out.
But the MAV is about to fall from the strong winds. Well, let's collect the soil samples and move on.
They go out in the storm, and the debris hits Watney.
Search for him. We cannot leave him.
Abort the mission. I repeat, abort the mission.
I don't think we can search for Mark Watney in this troublesome hour.
Everyone presumed that astronaut Mark Watney was no more. It was all over the media that Mark Watney was dead.
Oh no, my son. I had no idea about this. I should call the NASA department.
Hello.
Hi, this is Mark Watney's mother speaking. I've heard some problem had occurred during the flight. What happened? Is my son fine? What happened to him?
I'm sorry to say, Mrs. Watney, but your son has sacrificed his life for this mission. I'm sorry for your loss.
Back to the red planet, where Watney, who was unconscious, had gained consciousness. He found out that he had an antenna that wounded his stomach. He somehow got up and went inside the Ares 3 MAV. He used the medicines there to cure his wound.
Oh gosh, would you look at that? Ugh, this hurts. I have to do the treatment myself now.
Then he records the video for Hermes.
Hey guys, this is Mark Watney, the astronaut from the mission Ares C MAV. And yes, I'm alive. But I have limited food which would last me 3 years and 4 years if I ration. Now, I have to grow food in a place where nothing grows.
Watney knew it would be impossible to survive without food, so he planted the potatoes he found in their camp and used his excreta as manure.
Now, let's see if the potatoes grew.
But suddenly a cold storm came and destroyed the crops and the MAV's parts. Watney was disheartened and had lost hope. He knew now that he needs to move towards the Ares 4 landing site.
Okay, let's see. I have limited food and the Ares 4 landing site is very far away from Ares 3 landing site. Now, let's get going. But the problem is that I have only one working rover left on Mars.
Hermes, do you receive me?
Yes, sir.
I want you to go and rescue Mark Watney from the Ares 4 landing site.
He is alive?
Maybe.
Guys, do you think we should go? I mean, it will be dangerous there. Whatever just happened to Watney could have happened to any of us too.
Yes, we have to rescue our crewmate though.
Okay, I am now going to renovate some parts of the MAV of Ares 4. Okay, done. Hermes, you ready?
Yes, Watney.
Okay, launch.
Oh well, Watney is very far away.
Wait. I make a hole in my EVS suit and propel it forwards through the escaping air.
Okay, I'll catch you.
Watney catches up to Louise and grabs the rope holding her.
Hey Louis, I came back.
Yeah, can't believe it.
Welcome back, Watney.
Well, it was really an unforgettable experience.
And then they all return to Earth, and Mark Watney trains newcomers about the survival on the planet.
Thank you.
Thank you.
Thank you.
Namaste. My name is Akshay.
My name is Ishan.
My name is Arav.
Today's topic for today is pros and cons of space exploration.
Space exploration has its own pros and cons. So these are the pros of space exploration. Here's why scientists say that we need to explore space, as space has a lot of asteroids and meteorites. It is always better to know when they are coming so that we can somehow be prepared. This is done by launching satellites, and satellites send info about the certain asteroid, whether it is going to hit or not. This is a pro.
Conclusion. Scientists warn us before any asteroid and meteorite come into the Earth's surface. Yeah. And this is done. This is the signals done by the satellites. So we have enough time to prepare ourselves from them.
Solar flares are extremely dangerous and if not cared much about can kill so many people. First of all, what is a solar flare? Solar flares is a flash of light or a huge release of energy that converts magnetic energy of sun into heat or into light. It generates particles that could heat up the plasma in order of minutes to over 60 million Kelvin. And how do we know this? We know this by space weather. Space weather sees what happens on the sun and how it can affect us and on the space environment of other planets. With solar flare, we have a coronal mass ejection of the sun, which is a ball of solar energy which releases subatomic particles, which we know as solar particles.
Conclusion. Space exploration is very much required, or else we would be in danger anytime. The sun rays which can cause sunburns are very harmful to everybody's body.
With all these three things, all three things can make a solar storm which can affect us badly. So it is always better to know when a solar storm is coming. So space exploration is needed for that. This is also a pro space exploration that can also be used to colonize planets like Mars. And how? Elon Musk is doing it. It helps in humans not becoming extinct and saves so many people, but might cost a lot. But this is a pro.
Asteroid explore the space and find another place to live if our Earth cannot survive for much long, which can save billions of people's life. Now I pass it on to Aro.
There are many cons in space exploration. Some of these cons are in 2016, the budget for NASA was 19.3 billion. According to the figures released by the United States, it would only take 30 billion to end world hunger globally each year. If the money funneled to NASA were used to take care of Earth's basic needs, the United States could eradicate about 60% of the world's hunger on its own with a simple shift of money.
The expenditure of space is quite high because the rockets and satellites have expensive parts, and builders of most must take care of the fuel and parts and especially the engine. This is really challenging work and costs a lot.
Another con of space exploration is that if it fails, the whole money spent on it is gone to garbage.
If a particular mission is failed, then the money which is spent on the rocket or satellite is gone to waste.
In the space exploration is that the space rocket, when it's destroyed, can form a space waste around Earth's atmosphere. NASA is currently tracking more than 500,000 pieces of space junk that are orbiting our planet. These items will not go away unless we do something about it. We have created a ring of debris of garbage around our planet that could be devastating to future travelers.
Us humans also pollute the space. When a particular satellite is destroyed, the parts get damaged and it causes space waste.
We know how devastating human diseases have been to isolated pockets of humanity. When European colonists came to North America, smallpox killed up 90% of the local population because they lacked immunity to the diseases. It may have been exciting to visit new worlds or even meet new species like ourselves, but we may take the disease risk seriously. They could infect, or we could infect them, bring harm to one another. So these are the pros and cons of space exploration.
Thank you.
Namaste. Today I am going to explain you about my artwork which I have done on the topic space and scientific explorations. So, in my artwork, I have mainly focused upon India launching a rover to an unknown planet to get the closest picture possible of an eclipse. So, as you all know, eclipse play a very big role in Indian mythology and also look very beautiful. So, let's see my artwork. So this is my artwork. I hope you like it. Thank you.
Namaste everyone, my name is Darvik and today I'm going to present you one of my paintings. So this is my paintings. I have drawn Mars. I have drawn the Indian flag on Mars to indicate India is the first country to reach Mars. I have drawn two rockets to show that one is from ISRO and one is from NASA, and this indicates that astronauts will be landing on Mars soon. I have drawn a space shuttle to show that astronauts will take rock samples and water from the Mars. I have drawn the stars and constellations around Mars to show that there are many beautiful stars and constellations around Mars. This is completely fictional, but in the future, this someday may be true.
Namaste. It would have been interesting if we could know about the people who visited the space for the first time. Some students tried to go through the lives of those pioneers of some space travelers and understood their mindsets. Yuri Gagarin and Rakesh Sharma, to name a few.
Namaste, hi and hello. Welcome to this interview with Rakesh Sharma, Yuri Gagarin and Neil Armstrong. Looks like Neil and Yuri aren't here yet, so I will start with Rakesh Sharma. Namaste, Rakesh Sharma. In this interview, I want you to answer the questions honestly.
Sure, I always answer honestly.
Then should we get started? I will ask you 3 questions.
Sure, ask away.
Firstly, why did you want to become an astronaut and how does it feel to be the first Indian citizen to step on the moon?
When I was a child, I was too interested in things related to space, and I read a lot of books related to space and solar systems. Later, I developed the passion for that field and decided to choose it.
Tell us how it happened. Your journey from selection to finally making it aboard the Soyuz.
So let's first see how I have become an astronaut. First, I've joined the Indian Air Force. I then started passing a numeric levels in 1984 and was promoted to the squadron leader in 1982. To become a cosmonaut to go to space in 1984, I was the first Indian to enter space in Soviet rocket Soyuz T1.
Sare jahan se acha, Hindustan hamara. How did you feel when you uttered those famous lines describing how our country appeared from space?
When I was quoting these lines from the Soyuz aircraft, it was a proud moment for all Indians and me myself. I was at a conference with Indira Gandhi and other officials from Moscow. Our country looked beautiful from space. Being a patriotic Indian who is proud of the country's culture, I would like to tell you that our country has more than what it looks.
Hi, we are late?
We?
Yes, me and Neil Armstrong.
No, not at all. I was just finishing up this interview with Rakesh Sharma. Rakesh, your interview is over and now you can watch the others take their interviews.
Okay.
Yuri, I'll first question you. Your first question is, when in the shadow of Earth, is it possible to observe the surface through visor and does it blend together and is impossible to distinguish?
When flying over the dark side of the Earth was not at all visible. Neither was the horizon or the Earth, because there was nothing to tie into. The horizon could be seen in an erect form. Additionally, there was no visible sharp transition from the darkness of the Earth to the darkness of the sky. Only stars, but even so, it was difficult to determine which ones they were.
Okay, a good answer. I would like you to describe for us somewhat more in detail the sensation of weightlessness. What was different about it?
The difference is that when the person is in such a suspended state, he doesn't sit in a chair or he doesn't lie in his bed. The feeling, the sensation is as if you are lying on your chest. At first, it felt a weird sensation in your chest, but slowly you forget about it. I was eating, drinking, writing, reporting, and I was also using the telegraph key. Therefore, in my opinion, the length of the weightlessness that I experience does not affect the coordination or the productivity, nor it does make it more difficult.
Okay. I would like to know the following. The transition from elevated gravity during the G-force state to weightlessness, did you feel it?
Yes, I did. The G-force during the operation of the third stage was about 0.3 to 0.4 in all. So here on Earth, it would be a mere half the weight. And this transition to weightlessness was very gradual. I did not feel the separation of the ship and the end of the acceleration, but there was no difficulty.
And what about the transition from weightlessness to increased gravity? Did you feel it and how was it?
I did feel the transition from the weightlessness to increased gravity at a very gradual one. The g forces increase very gradually, very slowly, especially until 1 g, where the increases takes about 2 minutes, and then approximately in the first segment, the descent g forces grow somewhat faster, and then very quickly they reach about 6 or 7, and then go to 10 and even somewhat higher. It is increasingly quite slow, but I must say, but the decreasing is rapid.
What were your sensations while swallowing food and water in the conditions of weightlessness? Are they different from those on Earth?
When swallowing water or food, I didn't feel anything special. It works the same way as Earth. I didn't have any difficulty swallowing. It is the same way up as it is on Earth. Food travels through your throat into the stomach and so on.
Okay, thanks a lot for your answers. Now, finally, it's Neil Armstrong's chance to be interviewed.
Okay, I'm ready.
The first question for you is, why did you join the astronaut corps?
I joined to investigate the problems of flight in the vacuums of space.
What effect did the Apollo 1 tragedy have on you? Did it cause you to rethink your involvement in the program?
No, I don't think so. All of us that time came from the world of flight tests, and we were all aware of the risks. Disasters of that type just make you try harder. And if you are an astronaut, you have to take risks.
Compare the risks of flying in the space program with risks you faced at other times in your career, such as flying in wartime as a test pilot.
Risks in space flight were high. Risks in space flight testing were higher because it was my first time. Risks in a combat were highest because you might injure yourself anytime.
When did the words, "that's one small step," come to you?
I thought about it in the lunar module after landing, but prior to descending on the ladder to the surface.
Landing on the moon was particularly challenging. Talk a bit about that. The drama of overriding the autopilot, the fuel station, and finding a suitable place to land.
All the Apollo landings were performed manually. Pilots were unwilling to allow the computer guidance to make the landing and possibly stick a landing leg into a crater.
Thank you all for your cooperation. You all may leave now.
Okay, thanks. Bye.
Thank you very much. Goodbye.
These ideas may look weird at present, but you never know, these become a reality in the future. Thank you and namaste.